All right, so since I will be gone during 7th hour today, I thought we'd try something a little bit different. So today we're going to talk about 8.1, adding and subtracting polynomials. Actually, we're not going to add or subtract polynomials today, ironically. It is our first day covering this concept, and so we're going to talk mostly about what polynomials are. We're going to talk about a lot of the vocabulary that has to do with polynomials. A lot of it, if not all of it, might be new to you, depending on what you got in 8th grade. And a reminder that we're going to have a quiz over this vocabulary on Friday, as well as adding and subtracting polynomials on Friday. So to start off with the terminology here, blank, an expression that is either a numeral, a variable, or the product of a numeral and one or more variables. That is going to be a monomial. So it says a numeral, so that's just like a number, 7. A variable, x or x squared or y squared, or the product of a numeral and one or more variables. So you could have like 2xy or 3x squared, y squared. The main thing with the monomial is that it's not going to have any addition or subtraction signs, okay? So it's got to be all multiplication division going on, which is what's going on here with the 2 times x times y. All right, that's the monomial. Next, we have a coefficient. A coefficient is the number in front of the variable. That should be fairly familiar to you. So in 2x, that's the coefficient there, the 2. In 3x squared yz to the third, 3 is the coefficient. It's the number that is in front of the variable or variables. Okay, so those are your examples there. Next, we have term or terms. Terms are separated by addition or subtraction, and so terms are basically monomials separated by addition or subtraction. So each of these, 2x is a term, y is a term, 3z squared is a term, negative 4 is a term. All 4 of those are separate terms. Terms, again, are separated by addition or subtraction. So every time you see addition or subtraction, you have a new term. So this has 4 terms. Another little shortcut is that you're going to count the number of it's not going to let me change colors here. You're going to count the number of addition or subtraction signs, and there's going to be one more term than there are addition or subtraction signs. So since there's 3 addition or subtraction signs, you're going to have 4 terms. 1, 2, 3, 4. All right. There's my examples there. Like terms. We're familiar with the term like terms. We're used to looking at like 2x and negative 3x and saying those are like terms, or 4y and negative 2y. Those are like terms because they have the same variable. This is talking about the same variable and the same exponent. So 2x squared and 5x squared are like terms. But if we had 7y and 8y squared, that's not a like term. 8y squared is not a like term because it doesn't have the exact same exponent. So in order for something to be like terms, they have to have the exact same variables and the exact same exponents. If we look at a couple more real quick. 2xy, 3xy. Same variable, same exponents. Those are like terms. Negative 4x squared y to the third. 8x squared y to the third. They have the exact same variables and the exact same exponents. And so those are like terms as well. They have to have the same variable and the same exponent. That's a really important concept for adding and subtracting polynomials, as we'll talk about Wednesday and Thursday. There's my examples again. Next, we have a constant. A constant is just a number. This is a numeral or a number. The main thing here is that it's not a variable. Constant isn't going to have any variables. So you could have 7, 3, -7, even 3/4, 2.1. They're constants. There's no variables, okay? A polynomial is a sum of monomials. And so you've got this root word here. Oops. Yeah, this root word here. We know that mono means one, poly means multiple, and so polynomial is multiple monomials. And so examples of a polynomial: 2 plus x, x squared plus y, x squared plus y plus 7, x squared plus 7x plus 8. Those are all polynomials. They are adding monomials together. Okay? And then we have some special kinds of polynomials. A binomial. This means two, and so a binomial means two terms. And remember that terms are separated by addition or subtraction, and so a binomial is going to be just like this: 2x plus 1, or 3x squared minus 4x, 52x to the 60th power plus 1. The main thing here is that you have to have two terms. So you're going to have two monomials that make up the polynomial for a binomial. Similarly, trinomial. Tricycle. Tri means three. Trinomial. And since tri means three, a trinomial is going to have three terms. So typically you're going to see it with an x squared, an x, and a constant term. That's your most common trinomial. Something that has an x squared term, just an x term, and then a constant term. But as long as it has three terms, it is a trinomial. So you could have like 48x to the 7th power plus zx plus 12,000. I don't know. Lots of options there. As long as it has three terms and it is in simplified form, you're good to go. Speaking of simplified form, simplified form just means that we can't combine any like terms. So 2x plus 5x squared plus 4x, that's not simplified form because we can combine 4x and 2x because they have the same variable and the same exponent. The 5x squared cannot be combined with the 2x and the 4x because they don't have the same variable and the same exponent. So simplified form would be 5x squared plus 6x. Notice how I wrote the x squared term first. Typically, we're going to write the highest exponent first and then go on down the line. Sometimes that's hard to decide when you have like multiple variables and stuff going on, but for the most part, we're just going to deal with one variable within a polynomial anyway. The degrees of a variable in a monomial. Number of times that the variable occurs. And so the degree of x to the third power is 3 because x occurs 3 times. Because you have an exponent of 3, so it'd be x times x times x, so that's 3 times. And the degree of y is 1 because we know that if there's no exponent given, the exponent is 1. So degrees of a variable in a monomial, it's basically whatever the exponent is attached to that variable. Degree of a monomial, the sum of the degrees of its variables. And so if you have x squared y to the third, the degree is 5 because 2 plus 3 is 5. If you have x squared, the degree is 2 because there's no other variables. X to the third, y to the second, z to the third. That would give us a degree of 8. We're not really going to talk about the degree of a monomial very much. We're mostly going to be talking about the degree of the polynomial. Degree of a polynomial. It's the degree of the highest term, and so technically, if we had more than one variable, we would need to add those those exponents together to get the degree of that term. But suffices to say that most of them are going to just be x cubed or y to the third, just one variable. So you're going to find the highest exponent. That's 3. So the degree of this is 3. Hey, look, there it is. That'll end this video. I'll come back with another one to talk through your homework assignment.